Recording. Here we go. So I want you to write at the bottom of this sheet, there's an angle of elevation and an angle of depression. This one is a very sad angle. This one's a very happy angle. All right, an angle of elevation looks like this. This is a horizontal axis here, and that is an angle of depression. So this angle right here, or angle of elevation, it's like you look forward. All right, so everybody do this with me. Point one finger forward. Not at Ryan, just forward. You just happen to be my person. Okay, everybody, one arm forward, straight out from you, straight out. Come on, be brave. Come on, right there, okay? And then take your other arm on top of it and make an angle of elevation. So it goes up from there's a straight perpendicular line here, and then this angle right here between your armpits, that one is the angle of elevation. All right, we're gonna try again. Again, straight arm out. Straight arm next to it. This time, one is going down. This is an angle of depression. One stays horizontal. The one going down, this is the angle of depression. Okay, so an angle of depression looks like this. It has a flat line like that, and then an angle going down, and this is the angle of depression. Okay. Either. It doesn't matter if these ones cross or if they start at a certain place. Just one is horizontal and the other one's going down off it. Okay? All right, here we go. The hard part about these problems is not the SOHCAHTOA, I'm hoping. The hard part about these problems is drawing the picture and getting it right. Which is why I didn't draw a picture of any of these for you. We're going to draw them together. At a point A that is 123 feet from the base of a flagpole. All right, so I'm drawing, here's a flag. Anytime they say something like a flagpole or a building, you can assume that's a right angle there. All these drawings are going to have right angles in them anyway. That's why we're using SOHCAHTOA. And this is 123 feet. And this must be point A. The angle of elevation to the top of the flagpole. Whoop. Sometimes you just got to make that point A a little bigger to make your drawing work. This is 26 degrees and 40 minutes. Find the height of the flagpole. Now, I hate being in degrees and minutes, so let's change that right away. How do I change that into decimals? Right. Everybody take 40 divided by 60 in your calculator. Most of you probably already know that that's how much? 0.666666666, otherwise known as 2/3 or the devil's number, I guess. 26.67 degrees. Okay, and then we're supposed to find the height of the flagpole. All right, let's try it together. So what do we have? We got an angle here. This angle, this side is what? Adjacent. This side? Opposite. OA. What are we using? Tangent. Tangent of 26.67 degrees equals, let's see, OA, opposite over adjacent. To get x by itself, we cross multiply. X times 1 is x. Other side is 123 times the tangent of 26.67. Go ahead and put that in your calculator. 123 times the tangent. Let's go to the nearest tenth. If you did it right, you should get 61.8 feet. Turn to your partner and show them that you got 61.8 feet on your calculator. And everybody has to try this on your calculator because I don't want you to tell me after you do the whole assignment wrong that you were in radians and not degrees. Make sure you're in degrees. Show your partner. $123 times the tangent of 26.67. By the way, if you want a date, you can put 11/13 at the top of your notes. All right, this one is going to be worth a prize. I'm going to help you draw the picture. Everybody ready? All right, it's a cliff. All right, so we've got this big cliff. Okay, and I'm an excellent drawer, which is why I'm going to write the word cliff on my cliff, just in case we're confused about what that is. And then there's like the ocean down here, and look, it's an ocean. That's probably a right angle to the ocean right there, I'm guessing. And then we got a little lighthouse right here that's like shining a light like that way. Okay. I'm going to put LH on it for lighthouse. It says from the top of a 210-foot cliff, so this cliff is 210 feet. David observes a lighthouse that is 430 feet offshore. Where should I write 430?
Under the ocean.
On my waves. Deep under the ocean. 430 feet. Find the angle of depression from the top of the cliff to the base of the lighthouse. Okay, now this is hard to do. Do you remember? Show me with your arms right now. Point at me. Show me an angle of depression. It goes down. This is not an angle of depression. Look up. This is straight. This is the angle of depression. That's what you're trying to find. You're trying to find it going down. We want to know what this one is. Sure, you're going to have to figure out what this one is to figure that out, right? Okay. All right, you want to work with your partner now. Talk to each other. If both of you don't know what to do, call me over.
Actually, it doesn't equal that. That equals this thing. So it depends what height you find theta.
Remember, if you guys need my help, call me over. I'd be happy to help. Sleepy today?
Is it fine to 7 in decimal?
Huh?
Do they want it in minutes?
No, I'm fine with a decimal.